Okay guys, in this video I want you guys to know how to factor a polynomial by grouping. Okay? I'm talking about factoring polynomial by grouping. Now, let's go to this problem right here. So this is a typical problem where we're going to factor by grouping. We've seen this before because in quadratics we have a quadratic with a coefficient that's not 1 with x squared. Then we usually use this grouping technique to do it. But here we have 4 terms, and we're just going to go ahead and start group these together without having to do any other preliminary steps. So here I go. I'm just going to group these. Okay, 2x to the 6th plus 3x to the 4th. I've grouped that by itself. And what I'm going to do is I'm going to GCF factor just that group. Okay, it has x to the 4th in common. Okay, and what's left over is 2x squared plus 3. Okay? The part in blue, negative 2x squared minus 3, it has a negative 1 in common. What's left over is 2x squared plus 3. Take a negative out. What's nice about this, you guys, is that you can see we have 2 terms, and they have 2x squared plus 3 in common. So we're going to go ahead and take that out. What we have left over is x to the 4th minus 1. Now, we're not completely done. We're done with the grouping part of this. But we're not completely done because we can actually factor this little part right here. This is a difference of perfect squares, which we've talked about in class 2. So let's keep going. We're going to have this 2x squared plus 3. This will factor as a difference of perfect squares, so it'll be x squared minus 1, x squared plus 1. Well, that's interesting because we actually end up right here with another difference of perfect squares, so we can actually factor that again. So we'll just bring down our 2x squared plus 3. We factor this. Let me just highlight that with red. And we're going to factor this as x plus 1, x minus 1. This is a sum of perfect squares, so we can't factor that. It has to be a difference of perfect squares. And there we go. That's completely factored at this point. Okay. So put a box around this just to show that's our answer. So at this point, at the end of this video now, you should know how to factor by grouping. And also you should see the example within this, this problem where you factor by perfect squares, difference of perfect squares. Quick note, you guys. You'll use factor by grouping here because this is like one of our quadratics. Usually with a quadratic, you would have an x squared right here and an x, but this acts much the same way. In fact, we'll end up factoring it the same way because 4 is half of 8, just like 1 is half of 2. So this is what we call a quadratic form. Okay, and you just factor that exactly how you factored a problem like this when you had a quadratic. Okay, so at this point you should have a pretty good idea about how to factor by grouping and have a pretty good idea of what to do in other situations when you have a difference of perfect squares, and also start doing a quadratic form type factor. Okay.